Hi, I'm Aryan Chaudhary. This is my Physics 2212 Lab 1 charge tapes. So the table of contents are introduction, experiment with the duct tapes, model with glow script, comparison and analysis. So the introduction. The objective in this experiment, I will attempt the experiment to try and figure out the charge between the charge on the two charge tapes based on the distance between them. Then I would make a computation model that mimics the experiment using glow script and then compare the two. I have to predict the charge on the tape and then find out how many electrons deficient it is. Some of the key ideas in this experiment are as follows. The gravitational force, which is F force is equal to mass times the gravitation constant. Newton's second law, force is the equivalent to mass times acceleration, F is equal to ma. And electrical force, F is equal to kq, q upon r square, times r hat, where k is equal to 9 times 10 to the power 9. So the system and the surroundings. The system in this case is the charge tapes and the pen in the experiment. The surroundings are everything else, for instance the table and the book. Preview of the results are as follows. Electrical charge, the total number of electron deficient and a ratio of electrons are found as follows. So the experiment and its procedure. Making the U-tape. In order to make the U-tape, I folded one table slightly on one end so I could hold on to it as shown in the instructions. The length of the tape was 20 centimeter, which is 2 times 10 to the power minus 2 meters. To charge it, I placed one tape on the table and then stuck another tape on top of that. Then I pulled it off very quickly to make it charged. The image below illustrates how the process. Then the observations made. I know the tape was positively charged based on the following observations that I made. The two tapes that I made repelled each other. The U tape was attracted to the negatively charged pen, which therefore was positively charged. U tape was attracted to neutral objects, and it also interacted with my hand as shown in the instructions. The calculations. The image shows how the experiment was conducted. I tried balancing the U-tape on top of another as shown in the image provided. Then I measured the distance d between the two tapes in meters. Now since I have the distance between the two rods and since the force of gravity is equal to the electric force, which is one of the assumptions, I can use the following equations to calculate the force. Force is equal to kq square upon d square and F grav is equal to mg. And E equals to the electric force. The calculations that I made are as follows. So I knew the mass, length, width, and the separation distance, which are listed as follows. And from the following two equations of F grav and the electric force, I was able to find out the charge on the U tape. And since the charge on the tape was positive, it was electron deficient. And total number of electrons missing was found by dividing Q with the charge of one electron. So that came out to be 2 times 10 to the power 10 electrons. Then some other results. The area of the tape was 4.83 times 10 to the power minus 3. The total number of atoms was found by dividing this area with the average area of an atom, which is 10 to the power minus 20. And that came out to be 4.83 times 10 to the power 17. And then the ratio of electrons to atoms was found as follows. This is the glow script code. So I put the values of the constant K, electrons charge, atoms length, scale factor, and the tape's measurement as shown in the first section. Then I used the equation F elective is equal to minus F grav and F elective is equal to KQ square upon D square to calculate Q in the second section of the code. Moreover, I calculated the number of atoms and electrons as well as their ratio. This is the glow script code results. This is the results I got from my code. The charge of the tape came out to be 3.177 times 10 to the power minus 9. The number of deficient electrons came out to be 1.98 times 10 to the power 10. Number of atoms was so, and the ratio came out to be 2.55 times 10 to the power 7. In the image, the orange arrow is the electrical force, and the green arrow is the gravitational force that the object experiences. The code's results are more or less similar to the experiment. The differences are caused by the assumptions that were made in the next slide. Assumptions that we'll discuss in the next slide. Some of these assumptions were as follows. In the model, we assume that the charge tape is a point particle, which it isn't and has an area. The air resistance was ignored, and we assume that both tapes have the same charge, which isn't. So the conclusion, what if questions. What if the electron had a positive and protons negative charge? What would change about the observations? I believe the results would be the same since flipping of the charges would not affect the concept that like charges that repel and unlike charges attract, so we should see similar observations apart from flipping of the charges. Why is it important to handle the charge tapes as little as possible? And what happens if the charge tapes came in contact with your hands or the other objects? It was essential that I handle it correctly and carefully, since coming into contact with my hand or any other object may cause it to lose some charge that would hamper with the results and give an error. Thank you.